In 2035, an entire city already existed on Mars, and not a single human being had set foot on the red soil to build it. Not a makeshift base, not an emergency module. A complete underground city, with streets, farms, breathable air and running water, built from scratch by autonomous machines in less than a year. What you're about to see is how that was possible. It all began with a single spacecraft. A solitary point landing on a dead planet. But that craft carried no colonists. It carried the embryo of an entire civilization. Every compartment, every system, every piece of equipment had been designed with a single objective: to transform Mars into a place where humans could live. The first question was brutal in its simplicity. How do you power all of this? Before building anything, you need energy. And the first worker to set foot on Martian soil was not human. It was an autonomous rover, compact and silent, with a clear mission: to deploy the base's initial electrical grid. The solution chosen for this first phase was solar energy. Not rigid panels too heavy to transport in sufficient quantities, but thin film, flexible photovoltaic arrays, rolled up like carpets inside the spacecraft and unfurled directly onto the Martian dust. Two rovers working in sync fired a connecting cable between them, establishing the link needed to begin the great unrolling. The operation resembled a precise, calculated mechanical dance. As the days passed, more rovers were deployed. A team of 10 machines continuously expanded the solar field, fixing the panels to the ground to withstand the Martian winds. Thin, but surprisingly powerful. The result was a multi-hectare solar power station built entirely by robots in less than a week. Enough energy to power a small city. A remarkable engineering achievement for the first phase of construction. But there was a problem that no number of solar panels could resolve on its own. Mars's global dust storms. Capable of blocking sunlight for entire weeks, these storms posed an existential threat to any base that relied exclusively on solar energy. A permanent solution was needed. It arrived with the second spacecraft. At the heart of that payload was the core of the permanent power station, a compact nuclear fission reactor. Not the complex water-cooled type that comes to mind when one thinks of nuclear energy. This was a solid block of uranium design, using heat pipes to transfer the intense heat from the core. That heat then drove a Starlink engine, a simple piston with more than 200 years of proven history, which in turn drove a generator, producing constant, reliable electricity. To protect the base from the reactor's radiation, the solution was elegant in its simplicity. Dig a hole. The reactor was lowered into the Martian ground, using the red Earth itself as the primary shield. Buried beneath the sand, connected to the base by a transmission line, the nuclear core began beating at a steady rhythm, 24 hours a day, 7 days a week, immune to any storm. Solar during the day, nuclear during the night. A hybrid grid, the backbone of the first Martian city. With the energy problem resolved, the real work could begin. And the real work meant confronting the greatest obstacle of all. The surface of Mars is a death zone. With no magnetic field, the planet is constantly bombarded by solar radiation. Temperature variations are extreme, dramatic drops every single day. Living on the surface permanently is simply impossible. The only way to build a safe, habitable city was to go underground. The third spacecraft brought the answer. A next-generation tunnel boring machine, designed by artificial intelligence and built to drill through Martian rock. It was not merely a giant drill. It was an underground factory on wheels, capable of excavating, removing debris, and constructing the finished tunnel in a single continuous process. The machine was assembled and positioned in a launch trench, and then the great work began. Drilling on Mars presented unique challenges. The low gravity made it difficult for the machine to stabilize itself. so it used hydraulic clamps to brace against the tunnel walls as it advanced. At the front, the blades ground through the rock. At the rear, an automated train continuously removed the excavated debris. And that debris was not discarded. It was sent to a concrete factory on the surface, where the excavated rock was reprocessed and used to manufacture the very wall segments of the tunnel. A robotic arm installed these segments as the machine advanced, creating a finished tunnel behind it. What was excavated became what supported. Mars building Mars. The progress was constant, but a concrete tunnel is not hermetically sealed. To create a breathable habitat, a perfect sealant was required. The solution was a two-component epoxy mixed with Martian dust, which expanded like foam to fill every microscopic gap. Applied as a spray, it sealed every joint and every crack, creating a completely airtight environment. For the first time, a habitable space existed on Mars. The tunnels were the streets, but a city needs rooms. The boring machine excavated enormous underground caverns, the future homes, laboratories, and communal spaces of the base. A growing network of corridors and chambers took shape beneath the red sand. The design was redundant by principle. If one tunnel were compromised, there would always be at least two other routes, between any 2 points in the city. On the surface, almost nothing had changed. The true scale of the construction was completely hidden. With the air systems activated and the interior spaces taking shape, the next great challenge emerged: life itself. The fourth spacecraft brought no builders. It brought the tools to create life. A chemical factory designed to transform Mars's dead environment into the fundamental building blocks of a civilization. The first ingredient was water. There was no liquid water on the surface, but there was ice, buried meters beneath the dust. A drilling probe descended to an ancient, massive glacier of frozen water. The ice was melted and pumped to the surface. For the first time, liquid water flowed on Mars. The second ingredient was the Martian atmosphere itself. A giant compressor froze carbon dioxide directly from the planet's thin atmosphere. With water and energy, the first miracle became possible: electrolysis. Using electricity to split the water molecule into its components, breathable oxygen and hydrogen. The oxygen was captured and stored for the future colonists. The hydrogen was directed towards the second miracle: the Sabatier reaction, a chemical process with more than 100 years of history adapted for Mars. Combining hydrogen and carbon dioxide, the reaction produced two things: more water and methane. And methane is rocket fuel, the very same fuel used by the spacecraft to land. The factory was producing the fuel for the return journey to Earth. A spacecraft was being refueled on another planet. Energy, shelter, air, and water. The four pillars of survival, all manufactured on site from the resources of Mars itself. With these systems operational, the final piece of the life support puzzle could be built: the farms. The first seeds were planted in an underground garden, illuminated by synthetic light and powered by nuclear energy. And life found a way. The first Martian harvest grew beneath the red sand. A complete, self-sustaining ecosystem began to breathe. The factory also produced nitrogen, an essential ingredient for the farm's fertilizers. Nothing was wasted. A completely closed-loop agricultural system. It was not only fuel coming out of that factory, it was food. And it was precisely that difference which separated a temporary outpost from a permanent city. With the city built and the robotic army resting after its monumental task, a new countdown began on Earth. The next spacecraft's payload was not equipment, it was people, the first colonists. ready for a 7-month journey between two worlds, ready to arrive at a city that had been built for them. By machines, but for humans. The final descent, the touch of the ground, and then the first human steps, not merely on Mars, but inside a city. Walking towards the airlock, passing through the portal into a new civilization. Pressure equalized. The inner door opens. On the other side, clean, pressurized corridors. Green farms illuminated by a synthetic sun. Running water, fresh air, a home. The first city on Mars was not built by human hands. It was built by an army of robots, a testament to human ingenuity pushed to its most extreme limit. Forged in the red dust, powered by dreams and sustained by science, it represents something that goes far beyond engineering. It represents proof that humanity is capable of creating a home where before there was only emptiness. If you'd like to keep following what will be built next, subscribe to the channel now and give it a like. Every notification is one more step on this journey.